I was mistaken, I'm sorry, I didn't realize you were serving as the expert, I thought you were here just for fun. So I'll get you guys started, just relax for a few minutes, kind of lay out the ground rules. There's some very important things that I think whenever you are presenting to any group, whether it's a small group like this or a big auditorium full of people, any speaker or speaker panel really needs to know who they're talking to and what the knowledge level of the individuals are in aggregate, so you know how to pitch your presentation, right? So the goal is to be an effective communicator and to get your message across. So whenever you go into a room, you kind of want to gauge who's there, either do a little homework ahead of time about attendees to a conference, or do some askings of organizers of the meeting, who will be in the room, who am I talking to, so you can gauge your presentation accordingly. So I'm going to go through, we'll seem like a fairly awkward introduction. We're all going to introduce ourselves to you, so you kind of know where we're coming from. So when our questions come up, you know why we're asking those questions, okay? So I'm Dr. Frank Cole, I'm director of the Gemstone program. I drive a lot. I definitely always sleep deprived. I tend to be safe. I know absolutely nothing about the electrical brain signaling, capturing, and interpretation. I think the smell of cinnamon is a sleepy smell and not an exhilarating smell. I think the smell of peppermint is disgusting. I don't like peppermint. So what I'm coming from you is a position of a lay user of a technology maybe, and not necessarily from a technical data capturing and implementation of a device point of view. And we'll go around, if everyone can kind of mimic that kind of introduction, that'd be great. Kristen, you want to go ahead?
I'm Dr. Kristen Skendel, the Associate Director of the Gemstone program, and I think my expertise falls pretty much in line with Dr. Cole's on this, which is rare. I think you have more expertise than I do, but the same.
Okay.
I'm Alex Carroll. I'm the Agriculture and Natural Resources Librarian here at the University of Maryland, so I work with the departments in that college. I have essentially no formal training in neuroscience or neuropsychology either. However, I do have some experience in doing social science research.
Okay, go ahead.
I'm Dr. Anupama Govindarajan. I have a bit of an unusual background. I mean, I'm basically an electrical engineer, but the last 10 years I have spent in neural implants, so I don't have formal neuroscience or neurobiology background, but I design electrodes, implantable electrodes, so I understand the fact that when you go deeper into the brain, you get more data from the signals. So my work has been in intracellular recording, when you go inside specific cells and try to record from them. So I'm really excited about your proposal. I think it's a very nice proposal, and I'm looking forward to having more discussions with you guys.
I'm Dr. Aravind Srinivasan. I think I've met all of you.
I hope so.
Yeah. So I'm very interested in sensors and algorithms and those aspects of your work, and like some of the others, I have very little expertise in neuroscience, but I'm very interested in making sure you guys get a strong research expertise and are able to convey your ideas very well, and why a certain technique for lay users, why what you're saying is compelling versus many other alternatives.
Okay, well, that being said, hopefully it gives you a flavor of who you're speaking with. Hopefully it'll be a conversation. Another nugget I want to toss out to you guys is always remember whatever feedback we give you is solely for the purpose of making your product better. Your goal is not today. Your goal is 2 years from now. Your goal is a thesis 2 years from now in your senior year. Every bit of advice or criticism or commentary we provide you, either orally or written comments on your proposal, are solely meant for you to make it better. Take them, digest them, discuss them, think about them. As you become more and more proficient in this topic, you may be much better positioned to decide whether that's a good piece of advice or not a good piece of advice. Think it through, adopt what is helpful, discard the rest, but bear in mind that all of it is meant to be building blocks to make this a better project when you're finished. So take it with that spirit, anything that might come up, okay? And this is your jumping off point. This is when you're going from all the background, getting organized, getting planning, doing the background research, to hopefully jumping off to doing the work. So you want to make sure you have a good understanding and you know where you're headed, and that's part of our job, is help you aim in the right direction. Any questions before we get started? Okay, then the rest of the time's yours. Go.
Okay, we're umdROUTE, as you probably know. I guess I'm Paula, for those of you who don't know.
I'm Emily.
Hi, I'm Mark.
I'm Daffy.
And I'm Boy.
And so the goal of our project, as you probably read, is to try to use brain signals to increase the alertness of sleepy drivers. So, so I guess this is an issue because people that are sleepy, they're really bad at just foreseeing the negative consequences that will occur if they like drive when they're sleepy. So I guess the example that came to mind for me is that like if you ask like a newlywed couple if they're going to get divorced, then the chance is like 0%, right? So I guess the issue here is not to focus on getting them to get enough rest, but it's to make sure that when they are sleepy, that they can stay alert and can like keep the roads safe, not just for themselves, but also for other people. So this is like, I guess drowsy driving is pretty prevalent as found by the National Highway Traffic Safety Administration. They found that, I guess, definitely more than 10,000 crashes a year occur with drowsy driving as the primary cause. And also, this has resulted in more than like 1,150 deaths, which is pretty surprising because like sleep is the only factor and like it's the primary factor involved. It's not like the secondary, like, oh, they were drunk but also sleepy. No, it's like this could have been prevented very easily, and I guess it's a tragedy. So our goal is, our project is divided into 2 sections. So the first part is researching ways to keep people alert. So just we talked about whether or not we can use existing ways that people stay alert and try to make those more effective, such as like the smells that you mentioned, or the caffeine or music, something along those lines, possibly some sort of haptic feedback. And then the second part is the device creation of some sort of electroencephalography machine, which will basically read the changes in brain voltages, which can be interpreted and correlated strongly with your alertness. So, so we all refer to that as EEG. And we also were going to use electrooculography, which is pretty similar, but it just basically detects when you blink and your eye movements, and it's also pretty strongly correlated with your alertness level. So I guess the purpose of creating the device is to also encourage people to track their own mental health, kind of like if you know the Fitbit goes around your wrist and it basically tracks your movements throughout the day. So the headband, the EEG headband, will allow you to track your own mental alertness states and brain patterns throughout the day.
So there are 3 main senses that we can target when we're trying to keep a driver alert: the auditory, olfactory, and tactile. For auditory stimuli, they're good for where visual stimuli can be distracting, such as for drivers, because they have to constantly be focused on the road and the drivers around them. So one example of that is an auditory trivia game, and they have had studies where they have drivers listen to a multiple choice trivia questions, and they can actually choose from categories that they want themselves to keep it more interesting, and they can respond by pressing buttons on the steering wheel. And they found that interactive cognitive activities such as this actually have an immediate positive effect on EEG and brain activity signals, but the effects quickly dissipate right after the task ends. For olfactory stimuli, they've shown that peppermint and cinnamon and other smells like that actually do have an immediate positive impact on EEG signals, and smells like lavender actually do the opposite. And for tactile, normally these are used for relaxation, such as for massage chairs, but we're thinking maybe some sort of physical or haptic feedback system, such as the steering wheel vibrating if the driver's falling asleep could be pretty helpful. So normally when we're falling asleep at the wheel, there are a few methods that we'll try to use to keep awake, and the most common being rolling down the window, turning up the AC, listening to the radio, and drinking coffee. But most of these, the problem is they only usually work for a few minutes and then they stop working. And then for coffee, caffeine takes a while before it kicks in, so that's not an immediate solution either. Then there are rumble strips, and they've shown that these are actually really effective. They installed them on Pennsylvania Turnpike, and accidents decreased by over 70%. And they've shown similar results even in like Japan. However, the problem with rumble strips is it's not practical to install them over very large distances.
Okay, and I'm going to be talking about testing and investigation. This is mainly going to go over what we're going to do with the EEG device, looking at what we get out of the EEG device, stuff like that. There's going to be 3 parts of that. First off, we're going to practice with the device. Second, we're going to use focus groups to get more data, and then we're going to look at the data we got from everything. Okay, practice with the device. There's going to be There's 2 big reasons we want to do this. First off, it's going to give us something to do while we're waiting for IRB approval. And second off, it's going to give us some practice with the device, get us familiar with it, stuff like that. Okay, basically we're just going to perform tests on all the team members, look at the data we get off of that, drowsy versus non-drowsy, stuff like that. Get familiar with the device. And then we're going to use everything we've learned from the device to create tests for our focus group. Okay, focus groups. We're looking at basic college age range people. There are plenty of them around here, so that's handy. 18 to 22 years old, evenly divided between male and female participants. Okay, we're going to use tests we prepared earlier. We aren't exactly sure what we want to put in those tests yet, since we don't have the EEG with us. We did come up with a few characteristics for them, though. They're going to be pretty long, about 4 hours, give someone time to get tired from the test. The participant should be pretty alert during the beginning of the test, but because of the monotony in the driving simulator, they're gonna eventually become tired over time. We're gonna use a driving simulator because if we were using cars, people would probably crash them. So, and finally, we're gonna introduce stimuli during the end part of the test in order to see if we can wake the person up. Okay, examining the data. We're gonna try to isolate the different brain waves we're looking for. There are a few different types of brain waves: alpha, beta, theta. Drowsiness is indicated mostly by beta brain waves. Those are just specific frequency and amplitude of brain waves. So we're going to try to see if we can find those and look at how they correlate to how drowsy the person is. Next, we're going to check the effects of the stimuli, see when we introduce the stimuli, how it affected the brainwave patterns. That'll give us an idea of what stimuli was most effective in waking the person up. And after that, we're going to begin introduction of our actual device.
All right, so I think, I'm going to talk to you about some of the technical aspects of EEG. So as it turns out, the EEG is just an electrode that senses voltage on the surface of your head, or for surface of your brain. Well, we can't actually put things right inside the brain, as Dr. Govindarajan probably does, but we're going to be using something less accurate and put it on the surface of your brain, on the surface of your skull. And you get data that looks like this. This is actually not at all useful. This is data from an electrode, different electrodes around the brain. This is not at all useful, but this is actually very useful. You can't, for some reason, see at the bottom there's listed frequencies. And so what we're doing here is we're taking this function here and we're decomposing it into different sinusoidal functions restricted at each frequency. So right here is theta. It should go in order, so theta, alpha, beta, so on and so forth. And so you're able to see, like, actually this is also not helpful. You're not able to see any clear difference in alpha power or beta power. But
Why don't you just move that thing up?
Uh,
Get out of the presentation mode and just move the picture up.
yeah, there we go, okay. And each of these correspond to a different frequency that we've identified.
That's good, we can say it more.
Yeah, okay. Hit present again?
Yep, I did. It's good, take it. Sorry.
So what was your frequency range was locking it, so it's in hertz?
40, 60, 80 hertz.
Yeah, it's just the entire frequency range.
There you go.
So
Now we can see it all except the units, so the units are
Hertz.
hertz.
yes.
Got it.
So each lecture is a channel. So I already discussed this. So theta is strongly correlated with drowsiness. Theta is obviously one of the lowest ones. There's a band below that, and that's 0 to 4. That's basically means you're already asleep. And that's the first level of sleep, so you're not in REM sleep. Beta is very good. Beta is alert. Like that's, you don't, when you're taking an exam, you want to be in this area, so on. So we actually, so our project is to administer treatment variables, right? So we're going to be, maybe it's caffeine, maybe it's music, or, I mean, we talked to Dr. Blankenship yesterday. He said, we don't need caffeine, just have my wife sit in the front seat. So maybe it's Dr. Blankenship's wife, like different treatment variables that we'll administer, and we'll get different data from those. But putting it all in a, so again, we'll get data that looks like this, and so we won't really be able to tell any difference. But using principal component analysis, where basically we can get singular values, or like the top eigenvalues, and it's basically just so it just tells us the number of, like how strongly something is correlated with something else, assuming that they basically controlling for the variation. So we'll be able to see, and maybe we'll find that actually nothing is really effective. Like the only effective thing is to get sleep. Maybe that's what we'll find. We also we could just use algorithms provided by this one paper I was reading, Rushton and some others. They all provide algorithms. The problem is they all provide them with EEG data that comes directly from a lab, and well, those are just going to be a lot stronger. For one, we're going to be using fewer electrodes. We're not really sure how tightly fit the electrodes will be on your head. And honestly, at this point, it's very abstract. We're not really sure the accuracy of it until we actually start working with it. So we might have to use some different algorithms to maybe modify theirs, try some new things to get data that's more workable because of our specific context. The sample size, of course, for the others, the sample size is low. I don't think we are going to be able to go actually very large on sample size. So our sample size is also going to be somewhat low. But yeah, mainly we want to control for the different contexts that we're working in. But yeah, so Laura will talk about how we're doing this.
So I'll be covering the device and the simulator. So for our device, we would want to use multiple signals because each signal is individually not very accurate because of all the noise and other constraints that we have. So our first signal will be using the EEG headset Near Sky Mindwave. This is a cheap headband that you can just buy, and we're hoping to use that with an electroencephalogram to monitor the eye movements while we monitor the brain waves as well. The simulator that we will be hoping to use is the simulator developed by System Technologies Inc. This System Technology Inc. has been one of the major driving simulator companies out there, and supposedly they make very good driving simulators. In the case that our electroencephalogram and EEG do not work, we are also planning on using additional sensors, or maybe substituting some of the sensors to help increase accuracy of data and monitor alertness. So some of them are heart rate monitor. The heart rate monitor basically will measure heart rate variation, which is also strongly correlated with alertness levels. Facial recognition to monitor blinks and head movement. And a pressure sensor on the steering wheel or maybe on a glove. And this will allow for us to know when someone is drowsy, because when you're drowsy, your hands generally start to release. And in the case that we are unable to afford the driving simulator by Systems Technology Inc., we'll be creating our own driving simulator using a driving wheel, a computer, a projector, and a small room to mimic the situation inside a car. So our project is very feasible in terms of budget because everything comes up to around under $1,000, and in the future we are hoping to obtain IRB approval, and we currently are obtaining our EEG headset, and it's on its way to be here. And yeah. How do you stop this?
But I guess that concludes.
Yeah.
Good stuff.
Okay.
All right, good job. Okay, well, we traditionally start our discussion with our outside expert. So you can, it's fair game, and we like them to give as much feedback as they can possibly get, so have at it.
So could you give me some more information on how you resolve the frequency from what you record from the electrodes to, to the different frequencies?
Okay, so, well, I just tell you. So our output, so the electrode is producing something that's really erratic. So when you, I guess this has to do with like the Fourier transform. You're able to restrict on certain frequencies, and well, you have to kind of assume that it's a composition of sinusoidal functions. So then you can, I don't know, you can restrict on the different frequencies of the brain waves that you want to analyze, and then add them up, so sine of this frequency plus this frequency, and then fit it on top of the EEG data that you already have. But I would be in a much better position to answer that once we actually get some EEG data and we start doing it in MATLAB or wherever.
I'm looking for the reasoning behind it. I mean, how do you know that will, especially the alpha, theta, those levels, how do they correlate with drowsiness? I mean, what are the references that say that this is
Okay.
how you convert the data, and this data means you're drowsy?
They did the same thing. They used, so the papers that we've been reading, they used principal component analysis. So they just found that when you, when you put these people in driving simulations, the variables that were most strongly correlated with driving errors were, sorry, this is just one study that particularly looked at drowsy driving. The variables most strongly correlated were when theta bands go up. So when you restrict on the theta frequency, when those are higher, you see that the driver makes more mistakes. But in more generally, there's like different criteria that they use to assess when someone is drowsy, and I think most of these are survey sort of self-reported, but you can also use that to correlate with theta, alpha, so on.
So, but independent of simulations, isn't there any neuroscience research that says that, so forget about driving. So in general, that, the different brain states are, that this is the correlation with alpha, beta, and theta. Isn't there neuroscience work that talks about it?
Yeah,
There's been a few. I don't really have a source because it's hard to find one that's about something so, considerably basic in terms of the field, because So I have a old biology text, not old, but I have a psychology textbook from high school, and inside the psychology textbook there was a bunch of information that showed that brainwaves were strongly correlated with different states of alertness.
And I think they've done studies with ADHD. I guess that would fall more under like concentration rather than alertness specifically. But I guess they also have these games, I guess, where they have you maybe like move the object from one side of the screen to the other, or like NeuroSky. I think they have a game where you have to, like one of the headset companies has a game where you can actually like physically move objects based on like what the headset is outputting. So I guess they're just basing that off of this strong correlation between your like focus and concentration and your brain just emitting beta waves. So I guess it's just sort of like a correlation thing that companies have been using because it's useful.
So these games that you're talking about for ADHD, and usually they are electrodes on a cap, right, that is fitted tightly, and that can, mess up your hair, for example. And it's serious. When you're going for an important meeting, I don't want gel on my hair, from the electrode cap. So, so the kind of signals that you get from those kind of measurements, where the electrode contact to the skull, to the outside brain, is pretty tight, versus is going to be different from the portable headband that you have, and I just assume it's going to be a hairband around. So, how are you going to account for those differences in signal
The
quality?
games, they've used the headsets that go on the outside of your head also for them. They might be less accurate, but I guess they're still like adequate.
But the game has a visual stimulus, and you have to respond. So it is checking your response to the stimulus that they provide, versus this is going to be a recording event, right? I mean, when you're driving, you would find it hard to present them with visual stimuli, you have a ball that's dropping and you have to, with a bat, go underneath. Those are the very basic games that I played, at least when I was doing video games. Our kids play more advanced levels, but you cannot do that while driving, right? So, so I think there is a fundamental difference between the games that they have to measure those brain alertness levels and the brain alertness levels that you guys are proposing.
Okay. Yeah, we did find one reference where someone was able to use a dry electrode at like the back of the skull to get some pretty good readings on an EOG machine, electrooculogram. In terms of games, yeah,
so
we don't.
what electrode is that? Is that your MEMS electrode that you mentioned in the paper, or?
MEMS?
That's the one with the dry electrode. I don't know, Mark might be talking about something else, but that's the MEMS one was the one, forgot who it was written by, but yeah, they argued that a dry electrode was, almost as good as a gel wet electrode. But I think the important thing is they were able to get good contact with the skull, even though it was a dry electrode. That would probably be our biggest feasibility concern, is how would anyone really wear something that fits tightly around, or maybe
it's easy to make MEMS things. My background is in MEMS, so and my thesis was microneedles, so maybe this is a good good intersection. But it's cheap and fast to make them, and you make in bulk, right?
Mm.
But the point is, those electrodes are going to be piercing your skin, and people are not, to anchor it in position, and that may not be what someone would want to do on a daily basis. I mean, you have glucose patch testing, and you have skin kind of needles for allergy testing, but that's like once in a way. If you're going to wear that continuously, you don't want it to be invasive. So my concern here, coming back to this, is electroencephalography going to be sensitive enough for your purpose? Because when it is used, for example, in treatment of epilepsy, what happens in epilepsy is that there is, it's like an earthquake. So you have an epileptic center, and then there are these these waves that go out in radial patterns. Now that is an acute event that can be caught by an EEG device. When you're doing video game stimulation, it is, you're responding to the stimulus that they provide, and they're measuring it on the screen, like how many apples do you catch, that, what is that fruit game the kids play? Fruit Ninja, yeah. So how many fruits do you cut, or, those kind of things. So there is a measure, depending on your response. So if this is drowsiness, would EEG be sensitive enough to be able to just capture drowsiness? Because it's not a major event like epilepsy. The only epilepsy device that I know that can detect epilepsy before it occurs is implantable. It's from Neurobase. Robert Fisher, who is associated with bioengineering here. I mean, it's from his company. So those are implantable devices. So I was thinking, as we were walking, about augmenting your headband, and if you can use something like a MEMS gyroscope, which measures angular displacement. So usually when I drive and when I'm sleepy, I go like this. And that's a pretty sudden, roll of the head. So if you had a gyroscope attached to your headband, and that could detect the angular rotation, and that could then trigger a vibrator on that headband, which kind of wakes you up because you're sleeping. So something like that may be simpler to implement.
Yeah. Well, I think. Wait. So I'll go first. No, I started speaking first, and then Mark. So you said two things. The first thing was, I guess, that it won't be accurate enough.
May not be sensitive enough.
So yeah, or sensitive enough to actually get an accurate reading. I think we actually my expectation for it is not that it'll be at 90% accuracy or anything, or even the concept of drowsiness is sort of vague. We don't have a very well-defined, we don't have it well-defined as like epilepsy or something like that. So the idea is, if we can get it to, if someone's, obviously it's in a continuum, so if someone's drifting into the drowsiness range, we're able to consistently maybe just 70% of the time, 60% of the time, tell that person, okay, we believe that you're probably drowsy right now. That's enough to maybe use it in conjunction with maybe the gyroscope, maybe facial recognition, something like that. That's enough to get it to a very good probability, I think, in conjunction. I think that was our idea. And then you said something else, but I forgot. So, Mark.
Yeah. One of the advantages of using the EEG, we thought, if we did use the EEG, we'd be able to, find out if someone was nodding off ahead of time before they actually started nodding off. So, be able to wake them up before it became a big problem like that. We are thinking of integrating other sensors, like Daffy said, just to increase the accuracy of our EEG device.
So that means contact will be an issue. Because if you have dry sensors on a headband, you want to make sure that the sensor stays on the head, on the forehead, and different portions, or maybe change it to a cap or something like that, which is again tight fitting with a strap or something.
Okay.
Dr. Blankenship suggested a baseball cap. He was saying, our target audience is maybe truck drivers, and so, maybe we'll make it like baseball cap and put all the different. Yeah. So.
Well, I was just going to change topics slightly. I was looking at, when I was reading through this, what struck me was the study design itself, and you have a lot of variables you want to potentially expose. And in terms of the IRB, I think that this might be a big issue for you because, well, the music one I think is fine. I think that makes a lot of sense. When you start getting into caffeine and affecting temperature and affecting smells, there's a lot of potential health effects that you might not even consider at this point that you're exposing your participants to, and you have to account for all of that when you're designing the IRB. So that's something that I wanted to bring to your attention and maybe have you think about. And in terms of the music, I kind of focused on this because I think that's a really promising variable for you to look at. I think that there are less health effects to accommodate for there. But one of the things that jumped out at me is that you wanted to test different genres within music. And I want to caution against that idea because genres are a really soft distinction, right? Like where does country stop and rock begin or whatever you have. And so instead of thinking about genres, you might want to think about more discrete values you could use like beats per minute or decibel levels. So you're measuring how decibel level affects or how beats per minute, or using something more binary like you brought up audiobooks, so comparing music to audiobooks and seeing like that. But I would have had concerns about you thinking about exposing people to smells and substances like caffeine.
Okay.
We were talking about consulting team music. Can we get some?
And you gotta think, you're asking people to, with and without caffeine, you're actually administering a drug, and that's gonna be very hard to get approved.
But the tactile probably would be okay too, the vibration or the haptic feedback. Although, when I raise my flag on IRB is the electrode, talk about piercing electrode or placing electrode. Because you'll need to also, I think the piercing can't do. You'll need to figure out how you'll clean the device between testing as well. So that's something to talk to Team Adept about, and you may want to talk to them about how they did their IRB, since they developed a device that then they tested using electrode contact on the forearm. They were doing kind of like a video game for physical therapy. So they're a team you should talk to.
Cleaning the surface to be out with, some kind of isopropyl alcohol or something that is off the shelf, maybe something like that.
So going back to truck drivers, so I was also wondering about the domain. So you folks are interested in, let's say, 18 to 20-year-old, 22-year-old males and females, right? So, but if I think of bang for the buck, right? First of all, it's truck drivers who probably drive the most during nights when you're more likely to be sleepy. And if a truck driver, if they are involved in a crash, the effects are much more significant, right? So, what does the neuroscience say about, so the variation of alpha, beta, theta and its correlation with drowsiness as a function of age or gender, for instance, right? Most long distance truck drivers right now are probably male, it's my understanding. And I don't know, let's say they're in their 30s or 40s, right? So does this, you also need to look at, those variables, right?
Yeah, so that was one of our concerns. I think it's still feasible to adjust for that, because it is true that that age varies, but it varies in a consistent way, and it varies where someone who is perhaps, so as you get older, the frequency goes down. I don't know the exact number, but there's a paper that we could refer to get how fast the numbers degenerate when you get older per year or something. So all you would need to do maybe then to account for it is have the user input their age and then account for it that way. Also, we read papers about gender. There's some papers that say that there are differences or statistically significant differences. Some papers say there aren't any, and then some people, some say, males have higher frequency or are on average at a higher frequency, or females are on average at a higher frequency. So we're thinking that there probably isn't any significant difference here if all these papers are finding different. Maybe it's just due to their methods that they use. But if we find any, and I think it would be easy to find it if just use Stata to find it.
Okay.
If we find anything, we can control for it.
Also, is it known where the source of these signals is approximately in the brain? I mean, are these signals spherically symmetric, for example?
spherically symmetric. Can you define that?
So essentially, I mean, the intensity of the signal here is the same as the intensity of the signal here at any other point.
Oh, right.
No.
I think generally for attention is what we're looking at is in the prefrontal cortex, so like on the forehead. So we'll be generally looking for around there.
I guess you meant by spherically symmetric, a point here would be equivalent to a point here, but not equivalent to points here, or is that?
Yeah, so if it were somewhere in the center of the brain, right, as opposed to the prefrontal cortex, assuming that these 2 points are roughly the same distance from the center, it doesn't matter. But your electrodes are mainly forehead based, right? So I
Right.
assume it's more the frontal cortex, I see.
So, I mean, do you have data that drowsiness is in the frontal cortex, or, I mean, how did you determine, placing the electrodes on the forehead?
Anybody else? Okay. The electrodes were from one of the papers. So there's 20 different. There's a standard 20 placement for the electrodes, or 20 different electrodes that you have, and it's true. I think they're all actually useful for determining drowsiness, but the ones in the front and towards the back are better at determining this. Especially ones closer to the eyes are the best at determining drowsiness. But the more electrodes we have, probably the better data we'll be getting. We just can't. Maybe we can make a cap, but.
So my suggestion is that you visit a lab that actually does this kind of recording. Nitish Thakur's lab, or at least he will be able to give pointers. So this is in Johns Hopkins. So if you actually see the electrodes they're measuring, look at the signal strengths, and also visit a sleep apnea lab where they actually measure drowsiness and sleep, and then try to correlate what kind of electrodes would be useful, do we need a cap? Because even those cap-based electrodes are not portable. They're sitting in front of a computer, they're all wired, they're not wireless. So, to get that kind of data early on in the project, I think would be useful. So, you know exactly how to place it, why are you placing this, or is this the right design?
So one logistical thing. So I had told them that the folks at Lockheed Martin in Baltimore may have expertise in this, but you said that that's not the case. So how do we get in touch with some of these labs? I mean, even within UMD. So I was in touch both with Blankenship and the kinesiology department. So getting time and access to equipment has been challenging basically. So how do we access these? I mean, at Hopkins, this person, I've seen him once. I don't know him personally.
What about a Baltimore County where they might have more, they've got to have an
UMBC?
fMRI. Yeah, at UMBC, right?
Mhm.
I would think potentially labs there might be amenable to a visit. or
UMBC
something
or
like
University of Maryland, Baltimore? The
UMB.
medical school.
that. Yeah, UMB, yeah.
Yes.
Basically what we need to do is find out specifically which lab you want to try to visit. You just don't want to take everyone's time hunting around. And you make a simple request, and we can help you with that. You can do it on your own. They're either gonna say, yes, they won't be intrusive, you can come look all you want, or they'll say, no, we can't make it work. So just keep looking and asking. You have to hunt around and find the right source. That question is why we're kind of shifting gears a little bit. Your simulation testing, some skeptical comments about whether you're gonna be able to get this simulator to use, the simulator software. So everyone have a driver's license here?
Yeah.
Okay. No? Okay, well, 4 out of 5, not bad. You took driver's education? You used the simulator?
No.
They didn't require us.
Okay, there's no simulator used. Okay. What I was thinking is you could probably, I just did a real quick search here. If you chase down through the Maryland Department of Transportation, Motor Vehicle Administration, they have a whole safety program. For the cost of simulator software, they would probably give it to you if you explain what you're doing, what you're working on, why you're doing it. Also, the AAA had a whole program it is on driver safety, continuing safety, especially aimed at this age group. So you might want to see what you can chase down there. It's going to take a few contacts. And another one I didn't know existed was it's a national organization called the Governor's Highway Safety Association, which is a conglomeration of all state highway safety people. You they may be able to hook you up with a tried, tested, true simulator to use, which would eliminate that need to construct your own.
Yeah.
Okay, so that's just that, so I would pursue those angles. And then one specific comment is a 4-hour time period for your testing is a long time period. So you're gonna have a hard time finding volunteers who are gonna give you 4 hours, even though you're gonna give them $40, okay? And it's gonna be very critical what time of day that is held. You want someone to start out fresh and end up groggy, right?
Right.
So it seems to me we want to do it at the end of the day or late in the day. So think carefully if you can, whether you have enough individuals participating where you need to put a single individual through the whole course from fresh to groggy, or else you can get individuals for a much shorter period of time and somehow predetermine, either through the monitors or whatever, their state of alertness when they start. And then you could have a correlation between the initial state of alertness and their performance, instead of having someone sit in a room for 4 hours and get drowsy because your participation rate for that long block of time might be pretty low.
And in a similar vein, something that I thought about is that you might need to pilot test a test like this first, right? Where the first couple times you do it, something with your equipment might not work right, something about the way you're recording might not work right. So you might need to account for the fact that your first, 2 or 3 runs of this test might not give you any usable results at all. So thinking of the first couple sessions as pilot testing might be something to consider too.
Building off of that, you all talked about a lot of papers that you've read and different areas where you've gathered information, and I know you've done this quickly, because I know your timeline has been more compressed than some other teams. But how did you explore, assess, and integrate scholarly resources into the proposal writing process?
I guess I don't understand the question.
How did you find these papers? How did you know they were valid papers and that they weren't just someone sitting, writing a blog with no information? And then how did you decide which to include and which to just discard?
I guess for me, like at a certain point, the papers started saying like the same things, or like the same trends started emerging. So that's how I chose.
No, but Dr. Skindle's question is, how did you find these papers and how do you know that they are authoritative?
So, I guess in UMD libraries, it automatically tells you peer-reviewed or not. But in journals or in databases like ScienceDirect, actually we use ScienceDirect and PubMed the most after he tipped us off to it. So we use PubMed and ScienceDirect. I guess, to be fairly honest with you, I just assumed that they were peer-reviewed, but whenever we found them from the University of Maryland, it says peer-reviewed, so we used that. But they looked, like they were from.
They looked and smelled good.
Yeah, it wasn't Google searches. It was ScienceDirect and PubMed basically.
Don't underestimate Google searches, a lot of
Oh,
research
yeah.
Yeah.
out there, so.
Okay, we I think we're coming to a good point, but we want to make sure we give the team a chance to bounce back any questions to us that you may have that are not in direct response to the questions we asked you. So if there's anything on your minds or anything that's come up during this conversation that you want to clarify or get cleared up, Mark, I'm glad you got a notebook and started jotting down some notes because that's very, very important. So ask us anything you want while we're here gathered, because you may not get this opportunity soon.
Yeah. So for IRB approval, is there a form on a website that we're supposed to go to or something? I looked a little bit, but I didn't see it.
Yeah, we found an IRB sheet, but when we clicked the link from Gemstone, I think it went to an IRB for a different university.
So what you'll have to do is you'll all have to first complete what's called city training, CITI, and that essentially runs you through the basics of research ethics, and including mostly dealing with human research subjects, how you're going to manage the data that you collect, how you're going to separate their names from the collection or what have you. And then after you've all completed the training, you can submit an actual formal IRB application. If you just do a Google search of UMD IRB, it'll pull up the IRB office's webpage, and they have pretty extensive explanations on how that process unfolds, what the when the IRB meets, so when you can expect to have your case heard. And it is a lengthy process, so the sooner you can start on the city training, the better.
And the city training does look like you're on the University of Miami website, so that's probably what you fell into.
The city training is something that's accepted by many universities. It's not just a UMD specific. And then the irbnet.org is actually where you file the IRB through. So that also doesn't look like Maryland, but it's a central database and area. Your mentor will be the PI on that. So when you fill out the forms, you list Dr. Srinivasan, and then all of you are co-PIs. And whoever is the person who's heading up the IRB team can come meet with me, because I'm actually the liaison. So once you fill in everything, it gets sent to me, and I have to sign off on it before it can get sent to the IRB office.
Okay.
And you may want to talk to Dr. Srinivasan's senior team, Rio, probably Derek on there, as they've gone through IRB several times, and their most recent continuing review went through very quickly.
Okay. Other questions you have? No? So, what's the new name gonna be?
UMD sleep. UMD alert.
You don't have one yet?
Not yet.
Yeah, you'll be alert every Wednesday, the first of the
Yeah.
month.
We haven't spent any time thinking about it, but
We did come up with a few names, but none of them have to do with like the project we have
Yeah.
right now, so.
Well, I know you guys are really hung up on acronyms, but it doesn't have to be an acronym, it can be whatever you want. It just needs to be, because we are getting a lot of, growing amount of outside interest in team projects. And people are starting to refer to them as team this or team that, and they're getting to have an identity of their own. So if you come up with one that at least sounds like, so they, when they're looking at the list, go, oh, that's the sleep, or that's the drowsy, or that's the automobile, or that's the driver safety, or that's whatever it is. It's helpful for folks on the outside looking and trying to remember, what was that group? So, just spend a little time, have a little fun with it.
As you're working on your website, you can develop them.
Okay, any other questions from the group? And that, well, thank you very much.